Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel Height Year paper from 2019. This is paper 3. We're going to cover all the questions on this paper. So if you'd like to subscribe to this channel, clicking the button at the bottom, then you'll be able to see all the videos. So it's question 17, which is a question about graphs, and it's about recognizing different types of graphs. I'm going to go through each one in turn and try and explain how we know which one of these graphs it is. So we can see we're given at the bottom different choices as to what type of graph we've got, and what we need to do is we need to put the letter into the box and we need to match it up correctly. So for some of these, obviously you might know some and maybe you could work them out by trial and error or by knowing which ones are missing, but it's good to understand how all these graphs are formed. So the first one I'm going to look at is graph A, and this one actually is just a case of knowing what type of graphs we've got. We've got to sort of recognize what this is, and this graph A is actually a graph of sine. So it's this is a trigonometric graph. So it's a trig graph, and this would be if f of x. So f of x is like our y-axis here, and it's standing for a function of x. So it's very similar to saying y equals something. In this case, f of x is sine x. If we wanted to understand a couple of the values on it, we've got at 0, we'd be doing sine of 0. And if I put that into my calculator, I would get that sine 0 was equal to 0. So we can see this point here is 0. If I put in sine 90, I'd actually get that the answer was 1. And that's this point here corresponding to it. And so that value would be 1. If I put in sine of minus 90 into my calculator, then what I would get is minus 1. So that's this point here, minus 1. Sorry, that's minus 90. And this point here is minus 1. These points, if I put in sine of 180, so you could do this, you could test this graph out by just putting values into your calculator and seeing if they did give us this sort of shape. So sine 180 will be 0. Sine minus 180 is also 0. So that's these 2 points. That's 180 or minus 180. This is plus 180. So these points on our graph correspond to these points. So if we we could actually put in, let's have a look on our table. We can see f of x is a trigonometric function. Well, it is because it's a sine function. And the best thing I would recommend for this is just remembering your trigonometric functions. A similar one to that is a cos function, and that actually looks like this. So what's telling me that it's a sine or cos, if I go into the negative, it goes like that. What's telling me that it's a sine or cos graph? Well, this is f of x is cos x. If I did the graph like this, then it's a repeated sort of wave. That's a good way of looking at it. So if it's like a wave like this, so going up and down, and that's a trig function. So that's graph A, is that one. And I'm now going to look at this one, graph B. So what graph B is it's actually an inversely proportional. So let's look at why that is the case. So inversely proportional will be saying that f of x is actually, it's inversely proportional. It's I can write that as the proportional sign, and it's proportional to 1 over x. So let's have a look at what happens to that, we can again do some trial values if we want. So if we tried the value when x got very small, so I'm going to put in 1 over 0.1, we could actually see that we get a big value, that would be 10. And if x became even smaller, 1 over 0.01, then that would give me 100. And you can try these out on your calculator. So that corresponds to this part of the graph here. So we can see that when x is getting small, so it's getting close to this vertical axis, the actual value on the graph is shooting up. It's getting very, very big. And it's called an asymptote, which means a line that it will never ever touch. And so we can see that this curve here will never touch the vertical axis. It's just going to keep going up, getting bigger and bigger. Let's look at this part as x is getting large. Well, when x gets large, it's like having 1 over a big number. So if we say x is 100, well, that would give me 0.01. So it's getting small, and we can see that it's getting smaller. It's trying to go towards the horizontal axis, but it's never again going to touch. So it's an asymptote again. So these lines here for our curve are what's called asymptotes. Asymptotes. I hope I spelled that correctly. Asymptotes. So if we looked at the negative part of the graph, that would also be the same. So x is in the negative when it's to this side of the vertical line. X is negative, and we can see that then if we looked at dividing by a very small negative number, so as it gets to this part of the graph, we can see we're dividing 1 by a very small negative number, and that would give us a very big negative number, which is equivalent to the graph shooting down like that, as x got very small, a very high negative number. So let's say we're now dividing by 1 over minus 100, then the answer would be minus 0.01. So we can see we'd start to touch this axis here. So, or we'd get close to this axis, we'd never actually touch it again because it's an asymptote. That's what an asymptote is, a line which we never actually touch. So this is graph B, and we can say that that is inversely proportional to x. So that's graph B. I'll just tidy up this page again. So we'll now look at graph C. So graph C is one where, although as x increases, the function of x also increases. We can see that f of x is increasing more slowly than the value of x. And this one is actually the f of x is what I would say directly proportional. So proportional, that's the proportional sign, and it's directly proportional to the square root of x. So let's look at a couple of values. So we could say, well, if x is 1, then we can see that we'd be saying f of x is equal to the square root of 1, which is just 1. So we can see that f of x equals x at that point. And also a very important point to put in is, let's look at x equals 0. So we can see when x is 0, f of x is equal to the square root of 0, which is 0. So that's a giveaway because we know that it's going to go through the origin. So when x is 0, f of x is also 0. So if we was left with graph C and graph D as a choice, we'd have to choose graph C because we know that graph D doesn't go through the origin. So that's a giveaway, but I'm just going to look at another point here. Let's look at x equals 100. So when x equals 100, then f of x equals the square root of 100, which is 10. So we can see that f of x, as x increases, f of x starts to be smaller than actually x. Well, that's this graph, because we can see that x is getting big, going in this direction, and although f of x is increasing, it's not increasing quite as quickly. So graph C is the one that's directly proportional. So finally, we're looking at f of x as an exponential function, and if we've got this far, then we know it's got to be d if we're sure about the other answers. So we know it's got to be d. Let's have a look why that's the case. So, and what does an exponential function mean as well? Well, an exponential function is something involving powers. So it's like this. So we could have, as an example, it could be 10 to the power x. The 10 could be any number, but I'm just going to pick 10 to the power x. So x is actually the power. So exponential function means that x is the power. So it's not x to a power, it's that x is the power. And let's have a look what happens. So we'll look at, a good point to look at is for x equals 0, we could say, well, f of x, in fact, a nice way of looking at it is writing f of 0, because that's telling us straight away that we're looking at the value of x equals 0. So it's useful to understand this notation. So when x is 0, we can actually write f of 0 there, and that would be 10 to the power 0. And what we do know is that anything to the power 0 is actually equal to 1. And that corresponds to, here's the values of x is 0 along the vertical axis, and that would mean that that value there was 1. And whatever value chosen for the number part, the 10 to the power 0, 100 to the power 0, million to the power 0, they're all equal to 1. So any exponential is going to go through this point. Let's have a look at what happens when x is getting large. So in fact, we'll just look at we'll look at x equals 3, because it's going to get large very quickly, the f of x part. So f of 3 would be 10 to the power 3, which is 1,000. So already, by the time we put some values on here, by the time x was equal to 3, f of x would be 1,000. You can see this graph's not actually to scale. If we look at x equals 4, so we're looking at f of 4, that's 10 to the power 4, and that's 10,000. So you can see the graph is getting very big. Okay, if we look at values that are less than x is 0, so we'll look at x equals, I'm going to say, -2, then what we're looking at is f of -2, and that would be 10 to the -2. And using powers, we know that the minus means it's 1 over. So it's 1 over 10 to the power 2. And that's actually 1 over 100, which is 0.01. So we can see the graph starting to get very small. So at x equals 2 here, -2, then we can see we're starting to get close to the horizontal axis. And again, we've got this horizontal axis is actually an asymptote. because we're only going to touch it at minus infinity. We're never actually going to get there, in other words. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, and also visit our website, which is bestmathstutors.co.uk. Thanks for watching.